my name is Soumya and I welcome you to Revisedu, the learning platform. In the previous video lectures, we have considered a numerical problem where we saw it was not exactly a numerical problem, but we saw how the Coulomb's law is related to Newton's third law. Now, today we are going to do a derivation on a very interesting topic, which is dielectric constant represented by K or the relative permittivity. Right. So we have seen what is permittivity of free space, which was epsilon naught, which was used for Coulomb's law. Right. I hope you people have revised and remembered. So in this derivation, what we are going to do is we are going to derive a relation as it is stated by the topic. So before that, this is the diagram that we have considered for previous derivations also. Let us understand what the diagram says. So the diagram represents two point charges, which are Q1 and Q2, right, separated by some certain distance, which is R. So what happens in dielectric constant is what? Dielectric constant is actually the ratio of, we can define it as the ratio of the force in vacuum to the force in medium. So what we are doing is that the dielectric constant is defined as what? It is defined as the ratio between the force between two charges is separated by a certain distance in vacuum to the force between the same two charges separated by the same distance in the medium. Means the charges and the distance remains same, so the force changes due to the medium. Firstly, we are talking about the ratio of force in vacuum to the ratio of force in medium. Right. So charges remain the same, distance between them remains same. The only thing that changes is earlier it is in vacuum and then it comes in motion. So the ratio of such forces in vacuum to medium is your dielectric constant. Right. So let us see that how we can derive the formula for the same. So we are representing the force in vacuum by F subscript V and that in medium F subscript M. Fine. So let us consider this as equation number 1. This is equation 1, where we can say that the force in vacuum is what? It is 1 by 4 pi epsilon naught into Q1 Q2 by R square. So why we have written this? Because we already know that the formula for force in case of Coulomb's law is equal to K into Q1 Q2 by R square. Where K is what? It is 1 by 4 by epsilon naught. Fine. So this is what we have written, the value of force in vacuum. But what is the value of force in medium? So the value of force in medium will be represented by 1 by 4 pi epsilon M. Right. This naught stands for in vacuum. Right. But the value of epsilon in medium will be some different value. Right. So this will be what? Q1 Q2 by R square. Things remain same, distance remains same, but only thing that is changing is the permittivity of free space in vacuum and the permittivity of free space in a medium. Right. So these are the value of the two forces. Now what we are going is, we are going to substitute the values of equation 2 and 3 in your equation number 1 and see what the equation becomes. So we can say that K is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Right. And it will be in division. So what I can write is just the reciprocal of these terms. So 4 pi epsilon naught by 1 into R square upon Q1 by Q2. Right. Q1 into Q2. Let's divide the common terms. Right. So let's divide them. What is common? Not the epsilon naught, right? Only the 4 pi terms get cancelled. The charges are same, the distance is same, so distance and charges will be cancelled out. So what you can see is actually what is left. This implies that K is equal to your epsilon naught by epsilon M. That is what? The ratio of your permittivity in vacuum to permittivity of free space in a medium. Right? This is what you get. Fine. But there is an error. And what is the error? You can see, right, that what we have done is, we have written this epsilon in medium as epsilon naught, right? let us just write it as medium. So what you get is this value, right? This is epsilon m by epsilon naught. So this is what? This is the value, this is the final derivation that we were supposed to derive, and this thing is known as your relative permittivity. So why K is known as a relative permittivity as well as dielectric constant? Because over here we were talking about dielectric constant, but we saw that because of this relation that we got, we can see what? That it is the relative permittivity. Why? Because this is the ratio of the two permittivities in medium as well as free space, that is vacuum respectively, right? So epsilon m over here is known as what? Epsilon m over here is known as your absolute permittivity of medium, right? Absolute permittivity of medium. So this is the relation which is very important. So this was the key relation that we were finding out, right? In the next session we are going to see how the value of our Coulomb's law is going to change when we use this relation in your Coulomb's law formula. Till that, you should revise what we have done till now. This was a very simple and interesting derivation where you got to see what is relative permittivity and dielectric constant. Okay, this was all for today. Thank you.